Hello. We are in Chapter 6, Section 6.4, Equations Quadratic in Type. In this video, we're going to go over problem number 4, in which we are to solve this equation using U substitution. Well, when using U substitution, we always look for building blocks, expressions that are raised once to the first and once to the second power in our equation. The variable is x, so we find one here, one there. This x here is in the power of 1/3, which is equivalent to the cube root of x, of course, while in here is to the power of 2/3. Well, 2/3 is twice 1/3, so if we present this as x to the power of 1/3 squared, then we're getting exactly x to the power of 2/3. So it appears that x to the power of 1/3 will be our building block. But we also acknowledge that it really means the cube root of x, and we are more used to the radical notation, so we will rewrite our equation as 2 times the cube root of x squared minus 9 times the cube root of x plus 4 equals 0. Now, we will identify our building block that we'll substitute with u to be simply the cube root of x. So we let u be the cube root of x. That's our dictionary for the substitution, for the translation into the u language. And our equation in that u language is 2u squared minus 9u plus 4 equals 0. Now it's just a matter of solving that u equation in here. We acknowledge it is factorable, since 2 times 4 is 8, and two numbers that multiply to 8 and add to -9 are -1 and -8. So we can split our middle term into minus u and minus 8u, rewriting everything else as is. Then finish with factoring by grouping. In the first group, u is a common factor, and after factoring it out, it leaves us with 2u minus 1. And for our grouping to be successful, we have to make sure that in the second group, 2u minus 1 is also a factor. And indeed it is, if we factor out -4, because -4 times 2u is minus 8u, and -4 times -1 is plus 4. Still equals 0. Now there is a common factor of 2u minus 1, leaving us with u minus 4. And that's our u equation factored. Using the zero product property, we get 2u minus 1 equals 0, or u minus 4 equals 0. So after adding 1 to both sides of the first equation, we get 2u equals 1, and then dividing both sides by 2 results in u equals 1/2, while in the other one, adding 4 already gives us u equals 4. Again, those are our u solutions, and we need to use our dictionary, our substitution equation, in other words, to translate them back into the language of the original variable in our equation, which was x. We need to translate it back to the x language. So in these two equations stating the u solutions, we replace every occurrence of u with the cube root of x according to our dictionary. So we really have the cube root of x equals 1/2, or the cube root of x equals 4. And we just have to solve these equations for x. The cube root of x is already isolated in both of them, so it's enough to cube both sides in both of these equations. And that we get x equals 1/8, or x equals 64. It's always best to check those solutions in these radical equations to make sure that they work. The cube root of 1/8 is indeed 1/2, and the cube root of 64 is indeed 4. They do work. So those are our two solutions to the original equation. As always, I encourage you to plug them in and check, just to make sure.